Hello everyone, welcome to Practically, we bring learning alive. So today we are going to discuss this term 2 one shot chemistry atoms and molecules chapter. So let's wait for a few more students. Hi Arvind, how are you? So let's wait for few more students to join, then we will start the class. Okay, so now let's start the class. Hi Narsima, how are you? So let's start the class with atoms and molecules. Today we are going to discuss this, and today we are completing this whole chapter in one shot. So let's begin. Hi Venkat. Hi educational and technical videos. Good evening. So let's start this atoms and molecules, but before I should share this schedule with you. This is for class 9. So on these days we are conducting this one shot series. So today is 17th Feb. So today one shot science, that is for chemistry only. So this is for coding class. This is a schedule for coding class, and let's start with the atoms and molecules. Okay. So here, what do you understand by the term atom and molecule? What do you think? What is atom? What is molecule? Any idea? What is atom? So if I talk about atom and molecule, we know that many scientists have proposed this theory that atom is the smallest indivisible particle, which is given by Dalton. So he said that atom is the smallest indivisible particle. The first theory which was proposed by Dalton, and he says these lines. So let's begin with the theory. Let's see a video. So atoms and molecules. So in around 500 BC, India and Greek scientists together found this thing matter. And what they told about this matter, that Maharshi Kannad, which is an Indian scientist, so he told that if we divide the matter into smaller and smaller particle, we get a smallest particle which he termed Pramanu. Okay. So Pakuda Katyama, he said that atom exists in a combined state. Then Democritus and Leucippus, he told that if we divide the atom into a smallest unit, then it will termed as atom. Okay, so the indivisible particle is termed as atom, and atom is a word which is derived from a Greek word, that is atomos, that means a indivisible particle. So atom can't exist alone. They exist in the form of molecule. So as you have seen this, atom exists in the form of molecule. So what we get from here, this is the history of atom. So various scientists from India, from Greek, they have just predicted first thing, that our Maharshi Kannada, he says that whenever we divide a matter, we get a smallest particle which he termed Pramanu. Then other Greek scientists came and he told that matter consists of smallest unit which they term atom, and atom derived from the Greek word, that is atomos, and atomos means what? Indivisible particle. It is the smallest particle. Okay. So here if we talk about atom, then atom can't exist alone. They exist in the form of molecule like N2, H2, O2. So these are what? They exist in the form of molecule. So if we move further, then we got to know that atoms participate in your chemical reaction, correct? If atoms participate in chemical reaction, then what will happen? Then there are some laws which determine that chemical reaction. So they gave a term law of chemical combination. So there are certain laws which identify or which determine a chemical reaction, and they termed it as law of chemical combination. This law established after the experiment by Lavoisier and Joseph L. Proust. So Joseph L. Proust, Joseph L. Proust and Lavoisier, they together did they together give this law of chemical combination, and the chemical reaction between two or more substances give rise to product which is governed by certain laws called law of chemical combination. What does that mean? That means whenever your two or more substances react with each other, they will give rise to a new product. So whenever two or more substances react, they will give rise to a new product, and this whole reaction will govern by or will determine by these two laws of chemical combination. So these laws of chemical combination are used in your in governing or in determining your chemical reaction. Now let's see the history of this law of chemical combination. So Antoine L. Lavoisier, he gave this law of chemical combination, and the first law of chemical combination was law of conservation of mass, which was given by Lavoisier. Then Joseph L. Proust gave the law of definite proportion. So Lavoisier and Joseph L. Proust, both of them give this law of chemical combination. So let's start with the law of conservation of mass, which was given by Lavoisier in 1789. And what he stated that the matter can neither be created nor be destroyed in a chemical reaction, or simply I can say that total mass of the product is always equal to the total mass of the reactant. This is the law of conservation of mass. Let's see an experiment. So here we put some amount of your sodium or hydroxide in your this water, and sodium carbonate 1.3 gram in this conical flask. Then what will happen? We put that test tube in this conical flask. Okay. Now let's see what will happen. Close the lid of the conical flask. Weight the content of the flask. Now we have weighted the content of the flask and the test tube. Now we just move that flask so that the test tube will fall and the content of test tube and conical flask will mix. Now you can calculate the weight. Then you find that the total mass of the content does not change. They remain same. Now let's move toward the law of constant proportion, or we can say law of definite proportion. So here law of constant proportion was given by Joseph L. Proust. In a chemical substance, the elements are always present in definite proportion by mass. This was given by Joseph L. Proust, or we can say law of constant proportion or law of definite proportion. So here mass of hydrogen and mass of oxygen, they always combine in the ratio of 1:8 whenever water is formed. Whenever your water is formed, then they will always combine in the ratio of 1:8. Okay, I will explain later on, but first you can see this video. So nitrogen and hydrogen, this John Dalton give this thing that matter consists of a what? Small particles that we termed as your atom. So if two elements chemically combine two or more compound, then the weight of the one element is equal to the equal in the ratio to the other element. So they will combine in the fixed ratio. So this is element identical, that is atom 1 and atom 2 are same. So if we see this, then element 1 and element 2 are different. Atoms are indivisible particles which cannot be created nor be destroyed. We know this thing. So element 1, element 2, they together form a compound. Now this is sodium atom, this is chlorine atom. We know that sodium and chlorine always combine in the ratio of 1:1. If I talk about nitric oxide, and this is nitrogen dioxide, where we are having two oxygen atoms. So for nitrogen the mass is 14, for oxygen the mass is 16. So 14:16 ratio. If we simplify it, we will get the simplest ratio. Okay, so 14 gram for nitrogen, 16 gram for oxygen, they combine with each other to form nitric oxide. If we talk about nitrogen, oxygen, then nitrogen again 14 gram and oxygen 16, as there are 2 oxygen. So that's why the total mass will be 32 gram. So here you can see 1 oxygen mass 16. Here are 2 oxygen atoms. So they should be have same mass. So 16, 16, that gives you 32. So weight of oxygen NO 16, N2O 32, that means 1:2 is the ratio. So you can see here that this nitric oxide and nitrogen oxide, both are having this oxygen. And here these oxygen have simplest whole number ratio. So let's revise once again before moving to Dalton's atomic theory, what we have learned till now. First of all, there is a history of atom. Then there are 2 laws which are proposed by your L. Proust and Antonio L. Lavoisier. Both they have given laws of chemical combination. The first law of chemical combination is conservation of mass. That means in a particular chemical reaction, the mass is neither be created nor be destroyed. That means whatever the mass of the product we are obtaining, it is always equal to the mass of the reactant. Let's say we are having A plus B, which gives C plus D. Here, these are the products. If we are talking about A plus B, they are what? They are reactant. So A plus B, they are reactant, and C plus D, what are they? They are product. So product and reactant side, reactant and product side, both, if reactant is having 100 gram of mass, then the product side will be always equal to 100 gram. So this is the law of conservation of mass, that in a particular chemical reaction, your mass of the reactant is always equal to the mass of the product. What about law of constant proportion? Whenever 2 elements combine with each other, they do so in a whole number ratio. For example, your water. We are having 2 hydrogen atom, 1 oxygen atom, that is mass of 1 oxygen atom is 16. Mass of 1 hydrogen atom is 1. So 2 into 1, which gives us 2:16. If we simplify it, we will get 1:8. So mass, or I can say the ratio of hydrogen and oxygen in water compound is always 1:8. Doesn't matter from which source you are taking water. If you are taking water from a sea, if you are taking water from a lake, always your hydrogen and oxygen bear the simplest ratio of 1:8. Okay, so we have seen so many examples in the previous video. So this is the law of definite proportion. So these are the 2 laws. There are many more laws for this chemical combination, which you will learn in the higher classes. So for now, you need to just remember 2 laws, that is law of conservation of mass and law of definite proportion. Now we got to know about this laws. Okay, how the reaction in a particular reaction, in what ratio chemical or elements are combining with each other, how particular mass of a reactant is equal to mass of a product. We got to know everything now. Now the thing is, how atom will combine in a particular compound. If I am talking about a compound, there are many atoms. Okay, so in how these atoms are combining with each other. Now this theory was given by Dalton's atomic theory, or I can say this theory was given by Dalton, and we term this theory as Dalton atomic theory. So there are some points which he gave. Every matter is made up of very small or tiny particle, which we call atom. So every matter is made up of a smallest particle, which we term as atom. Next, atoms are not divisible. and cannot be created or destroyed in a chemical reaction. If I talk about a particular chemical reaction, then atoms neither be created nor be destroyed whenever a chemical reaction will take place. Only the bond formation will take place. Some bonds will break, some bond will make up. So what will happen? Only bond formation or bond breakage is there, but there is no destruction or formation of any new atom. So atoms are not divisible. That means you can't break atom at all. So which is a wrong, we will get it to know it later on. But what Dalton said, that atoms are not divisible. You can't further divide the atom. It is the smallest unit and there are no subparticles. But we know that, as we have learned it all, that atom consists of subparticles, that is electron, proton and neutron. So he told that atoms are not divisible and cannot be created or destroyed in a chemical reaction. So the third thing, all atoms of a given element are same in size, mass and chemical properties. If I talk about a particular atom, let's say I have taken this hydrogen molecule, that is H2. What do you understand by the term H2? That means there are two atoms of hydrogen. If I want to draw a structure for hydrogen, how can I draw? This is hydrogen. It is having only one electron. If I talk about another hydrogen atom, then the structure will remain same. So if there are same atoms, then they will resemble same. So all atoms of a given element are same in size, mass and chemical property. Let's say if I talk about hydrogen element, then how many atoms are there? Millions of atoms are there. So each and every element, each and every atom of that particular hydrogen element is same in size, in mass and in chemical properties. They will show the same chemical property. Atom of different element, atom of different element are different in size, mass and chemical properties if there are different elements. Like your water. In water we are having two elements, that is hydrogen and oxygen. Now if I talk about hydrogen and oxygen, the atomic number for hydrogen is 1. For oxygen it is 8. So they will differ in size, they will differ in your chemical properties, they will differ in the mass, as the mass of hydrogen is 1. For mass of oxygen it is 16. So you can see that if there are different atoms, then they have different properties. If there are same atoms, then they will possess similar properties. This is the main thing they want to tell. Atoms combine in the ratio of small whole number to form compound. Same way here, if you see that water 2:1, this is the combining ratio for water. There are 2 hydrogen atom and 1 oxygen atom. So water is forming by combining hydrogen and oxygen. Now after combining, we get the ratio of 2:1. So this is the whole number. Whole number means which are starting from 0. So whole number are those numbers which start from 0, 1, 2, 3, 4 and so on. So these are combining in the simplest ratio. That means they won't combine like this, 2.5 is to 1.5, not in decimal form, only in the smallest whole numbers. So they want to say this, atoms combine in the ratio of a small whole number to form compound. They won't be in the form of decimal or in the form of any rational or similarly. That means it comes around your decimal only. Okay. The relative number and kinds of atom are constant in a given compound. That means if there are a particular atom, then your number of atoms and kinds of atoms are same or are constant. That means if we are taking a hydrogen or a water molecule, then your hydrogen and oxygen, we always have to take 2 hydrogen and 1 oxygen to form a water. So this is what Dalton's atomic theory. Now in your exam, how the question can be asked. So if I talk about the question, Give the postulate of Dalton's atomic theory. This is the question. So how will you answer this? These all points you should write. This may be your 4-mark question, this may be your 3-mark question. But less than this, they won't ask. So you have to give the postulate for Dalton atomic theory. If it is of 2 marks, then they will ask for 2 or 3 points of Dalton atomic theory. So you should write in this manner. So the question says, give the postulate of Dalton's atomic theory. So every matter is made up of very small or tiny particles that we call as atom. Atoms are not divisible and cannot be created or destroyed in a chemical reaction. All atoms of a given element are same in size, mass and chemical property. Atoms of different element are different in size, mass and chemical property. Atoms combine in the ratio of a small whole number to form compound. The relative number and kind of atom are constant in a given compound. This you should write there. So that you will get a full mark. So these are the points you should remember whenever you are writing a Dalton atomic theory. Okay. So now let's talk about atom. If I am talking about atom, that we know that atom is very, very small. Can we see with our naked eyes? No, we can't. We have to see from your microscope, which we call electron microscope. From there we can see the atom. That means atom is very, very small. Okay. If I talk about the size of atom, then we calculate the size in nanometer. So this is the atom which we consider it will be in a spherical shape. So if I talk about radius, then the radius will be from your nucleus to the periphery or to the circumference. This is the atomic radius. This we called as atomic radius. So what is atomic radius? The distance between nucleus of the atom to the periphery or to the circumference of the circle. So here, if I talk about atom, then atom are the smallest particle of an element which can take part in a chemical reaction. So who will take part in the chemical reaction? Is this compound or your molecule? It is your atom who take part in a chemical reaction. So atoms are the smallest particle and they take part in the chemical reaction, and the size of the atom is very, very small. So we calculate it in nanometers. And what is nanometer? If I talk about 1 nanometer, then it means how many meter? 10 to the power minus 9 meter. So this is 1 nanometer is equal to 10 ki power minus 9, or if we want to do it opposite, that 1 meter is equal to 10 ki power 9 nanometer. So that we got to know 10 ki power minus 9. That means we have to put that much 9 zeros before your 1 and put a decimal. That means a very small value. That much radius. So this means the atoms are very, very, very small. You can't see it with your naked eyes. You need a special device which we call your electron microscope. From there we can see the size of the atom. Let's see a video for this atom. So atom symbol and atomic mass. So what is an atom? If I talk about atom, then atoms are indivisible particle making up matter. Whenever these particles together combine, they will form a matter. How big are atoms? Let's see. This is the atomic radius. Now this atomic radius or this atom we can see from the electron microscope. If I talk about the atomic radius of your atom, it lies in the range of your nanometer. And if I want to say 1 meter is equal to 10 ki power 9 nanometer. Now let's see the symbols. So first symbol was given by John Dalton. So let's say your hydrogen, this is the symbol of your hydrogen, and this 2 represent how much quantity it is or how much atoms are there in the hydrogen. Now these are the symbol, like this is a symbol for hydrogen, carbon, oxygen, phosphorus, sulfur, iron, copper, lead, silver, gold, platinum, and mercury. These all are the symbols which are given by your John Dalton. Then Berzelius came and he said that we should write the symbol in the form of letters like oxygen as O. So IUPAC is the International Union of Pure and Applied Chemistry. They gave the name, and from that name they took their letters, and they will approve this that whenever we are writing a symbol, we should write in the form of their letter. Okay. So hydrogen we are having H, for bromine we are having symbol Br. Like for magnesium, capital M and small g. So first letter we should represent in the capital and second letter we can represent in the small. Now iron, Fe, sodium, Na, potassium, they came from the Greek word. Like for iron, the symbol is Fe. So it should be from I, but the Greek name is ferrum. For sodium, Na, that means natrium. It comes from the word natrium. For potassium, it comes from the word kalium. So these are the symbol like element, and then there is symbol. Aluminium symbol is capital A, small l. Argon, capital A, small r. Barium, capital B, small a. Then boron, capital B. Bromine, Br. Calcium, Ca. Carbon, C. Chlorine, Cl. These you should remember whenever it is very helpful whenever you are writing a chemical formula. For cobalt it is Co, for copper it is Cu, for fluorine F, gold Au, hydrogen H, iodine I, and iron Fe, and lead Pb. So remember these all element and their symbol like magnesium Mg, neon Ne, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U, zinc Zn. So these are the symbol and these are the element. So if I talk about atomic mass, then atomic mass of an element is very small. So we can determine it by mass spectrometer. So if there are two atoms, atom 1 and atom 2, so they are, if I want to calculate the mass, then I have to calculate by taking them as a relative mass. So system of atomic mass was given in 1961, and it was considered that carbon 12 will be the relative atom for this. So here mass of carbon 12 means 12 atomic mass unit, that is 12 AMU. AMU stands for the atomic mass unit. So if I want to calculate 1 AMU, it is the 1/12 of the mass of the carbon 12. Carbon 12 is the isotope of carbon which is having 12 proton, 12 electron and 12 neutron. So 1 AMU equals to mass of one atom of carbon upon 12, which comes out to be 1.66054 into 10 to the power minus 24 gram. Now these all are the atoms, and whenever we want to calculate the atomic mass for these atoms, we have to take relative to the carbon 12, or we have to just do it 1/12 of that particular carbon 12. Let's say the average relative mass of an atom of an element as compared to the mass of atom carbon taken as 12. Let's say for hydrogen, we write the mass of hydrogen and write the mass of your carbon 12. It comes out to be around 1.007825 AMU. That means around 1. So that's why the atomic mass of hydrogen will be 1 only. So if you see the atomic mass of the element, which is also present in your NCERT table, so remember these: hydrogen atomic mass 1, carbon 12, nitrogen 14, oxygen 16, then your sodium it is 23. Let's see for other elements also. For magnesium it is 24, for sulfur it is what, 32, for chlorine it is 35.5, for calcium it is 40. So you need to remember all these elements. So here if I talk about the symbols and all what we have discussed in this video. So first of all, we have talked about atom size. So you have seen that how small an atom is. Then we move towards your atomic mass. Whenever you want to calculate the atomic mass, then you have to take carbon 12 as a standard. So basically we are calculating the atomic mass of a particular atom that is mass into 1/12 of your carbon 12, whatever one mass of your carbon 12 atom is. So this is given by your atomic mass. So from here what we have seen, if we put the mass of hydrogen and divide it by the mass of your carbon 12, then what we are getting? We are getting something 1.077 around this value. So that is approximately equal to 1. That's why we can say that the atomic mass of hydrogen will be 1 only. Okay. So these are the symbols. So first these symbols were given by John Dalton, and then Berzelius came and he said, why we are using these symbols? We can represent these elements in the form of your letters. Let's say for your hydrogen, we can represent capital H. This is the symbol for hydrogen. For phosphorus, we use P, capital P. For carbon, we use capital C. For oxygen, we can use capital O. So these are the symbols. But what about sodium? If I want to write the symbol for sodium, it should be either S or SO. But why it is Na? Because they derived from the Latin word that is natrium. Iron derived from ferrium. Potassium, why it is K? Because it is derived from the Latin word that is gallium. So these are derived from these words, that's why their name or their symbol are NaK. And your what else is there? Sodium, potassium and your ferrum, that is Fe. Because if iron, if you want to write the symbol for iron, it should be I or IR. But the symbol is Fe, capital F, small e, that is ferrum. So Fe means ferrum, that is it is derived from the Latin word. So who will give these names to these elements? Is there any particular community or particular institution who will just name these particular elements or atoms? So who is that? That is your IUPAC. IUPAC stands for International Union for Pure and Applied Chemistry. It will set all the rules for your naming, giving symbols to these elements. So here, element name and symbol. This is the table which is present in your NCERT. So you should remember all these symbols. Why you should need to remember all these symbols? Because whenever you are writing any chemical formula or you are solving any question, then you should know these symbols. If you don't know this symbol, then how will you represent that particular compound or particular molecule? Okay, so these are the symbols you should remember. Now, if I talk about molecule, we have talked about atom. Can you tell me the difference between an atom and a molecule? What is the difference between atom and molecule? If I am talking about atom, then atom can't exist alone. So it is dependent. So they will combine together to form an element. But element can exist. If I talk about oxygen, okay, if I am talking about oxygen, if it is oxygen atom, then what they will do? They will combine with each other to form O2. What is this O2? This is a molecule. Now O2 will be your independent in nature. It can exist alone. But this oxygen, it can't exist alone. So atoms are dependent, or you simply can say they can't exist alone. But this O2, or I can say molecule, they can exist alone. Like your hydrogen. Hydrogen always you find in the form of H2. Okay. For nitrogen, you will find in the form of N2. Oxygen, you will find in the form of O2. So what are these? These are the molecules. So molecules are just combining by same or different atom. So they will give rise to that particular molecule. So a molecule can be defined as the smallest particle of an element or a compound that is capable of independent existence. Remember this word. This is the most important word. Whenever there is an independent existence, that means it will exist. Okay. So it will be your molecule. If there is an atom, it can't exist alone, and shows all the property of that substance. So molecule of an element constitute the same type of atom. If I am talking about oxygen molecule, so it will have only oxygen atom in it. Molecule of a compound join together in definite proportion and constitute different type of atom. That means they will combine in a simple ratio. Okay. So all these are the properties of that molecule. So they can ask you differentiate between atom and molecule. Okay. Now let's talk about atomicity. Now what is atomicity? We have learnt about this molecule. Molecule are those smallest particle of an element or a compound that can exist independently. But what about this atomicity? Actually, how the atoms are combining with each other, it determines its atomicity. So let's say if I talk about argon or any noble gas, then their atomicity is they are monoatomic. Why they are monoatomic, not di or not tri? Because they are monoatomic because they are stable in their particular state. Like for argon, for helium, for neon, they are stable. Let's say for your helium, how many atoms are there or how many electrons are there? 2 electrons are there. So this is nucleus, 2 electrons in the first shell. So they are quite stable. So they don't want to get react with any other atom. Why? Because they are in the stable position. So they can exist alone. So that's why argon is also a monatomic, because this is a noble gas. We know that noble gases are stable because they have completely filled their octet. So they don't want to get react. So they will stay as monoatomic. Helium, this is also monoatomic. But what about oxygen? Why oxygen form a diatomic molecule? Let's talk about oxygen. So if I talk about oxygen, then how many electron it is having in the valence shell? So 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Now, if I want to just satisfy their valency, so oxygen have 6 valence electron. How many electrons they would require? 2 more electrons. So what they will do? They will share these electrons and complete their octet. So now every oxygen will have 8 electron in its octet. So they have completed their octet and they will form O2. So why oxygen is diatomic? Because if it is nascent oxygen, that is single oxygen, if it is single oxygen, then it will have what? It will have only 6 electrons. Its octet is not complete. So what we need to do? We need to share the electrons so that both the oxygen have fully filled their octet. So that's why oxygen is diatomic. You always see whenever you write a equation or reaction, you will always write oxygen in the form of O2. So these are very important. If you know the atomicity, you can write the chemical equation. So for sulfur, it is polyatomic because sulfur exists as S8. So we term it as polyatomic. More than 4, we term it as polyatomic. Nitrogen is a diatomic because it exists as N2. For chlorine, it exists as Cl2. For phosphorus, it exists as P4. That's why it is written over there tetraatomic. Tetra means 4. So tetraatomic means 4. That's why phosphorus is phosphorus always combine as P4, that's why it is tetraatomic. So let's see an example of writing a chemical reaction. So whenever I want to write a chemical reaction for water, so how will I write? Hydrogen plus oxygen will give you water. This is how I write. I have not written hydrogen plus oxygen gives me H2O. This is wrong. Why? Because if you see that hydrogen and oxygen are diatomic, so they will exist as H2O2, which gives us H2O. Okay, so whenever, if you know the atomicity, you can write the particular element or particular atom or particular compound in the right form. So this is the correct your equation. If we try to balance it, what I can do is I put half here. So now this is balanced. 2 hydrogen, half is cancelled. So 2 is cancelled by this half. So we are getting only single oxygen, that is H2O. Okay. So any doubt till here? If anyone has any doubt, then they do ask. Okay. So these are the element. These are their atomicity. Okay. This is how they combine in the nature. Now, can you give an example in each of the following cases? A divalent anion, a trivalent cation, a monovalent anion. Can you give the example of these anion and cations? Anyone who can give these answers? I'll wait. Any example of this divalent anion, a trivalent cation or a monovalent cation? Any example you remember? This is how the question can be asked in your exams. So you need to prepare very well. Okay. So, okay, I will give this answer. For a divalent anion, di means 2. Okay, and it is anion. Anion means negative charge. So divalent means 2 having negative charge. So what is the example of divalent? That is, ma'am, A. Aslam, A. I am asking for example. You need to give example for each of the following, this like as a divalent cation, which one is a trivalent cation. So you need to give an example. So I will tell. So oxygen, you have seen that oxygen as O2 negative. Okay. Why O2 negative? Because it has the valency of 2 and it will lose electron. We will see this. Aslam, it's not a MCQ type question. Okay. So you need to give the example. A divalent anion, O2 is the example for your divalent anion. A trivalent cation as you have seen Al tripositive. We will learn this ions, cation, what is anion in the later on slide. But for now, you need to just learn this. So for a divalent anion, it is O2 negative. For a trivalent cation, it is Al3 positive. And monovalent anion, monovalent means 1. Anion means negative. Cl negative or F negative, any you can put. So these are having this fluorine, these are having -1 valencies, or you can say 1 valency. If I talk about aluminium, it is having 3 valency. For oxygen, it is having 2 valency. Okay. So these are the example. For the divalent, O2 negative. For a trivalent, it is Al tripositive. For a monovalent, it should be second. So for a trivalent, for a monovalent, it should be Cl negative. So these are the example. So this can be asked in your exam. So this is how you need to answer, or this is how you need to remember. Okay, so if they are asking for anion, that means negative, cation, that means positive, then again anion, that means negative. Divalent means 2, tri means 3, mono means 1. So it is having 2 valency, it is having 3 valency, it is having only 1 valency. Okay. Now let's talk about ions. What are ions? Now listen it very carefully, because these are very important, or this is a very important concept for your exam. Ions. What are ions? We are having atoms. Some of the atoms have completely filled their octet and some of them are not. So what are these ions? Ions are the charge carriers, or they are carrying charge. If I talk about sodium, this is sodium atom. If I put positive over here, then it will be what? Ion. It will be termed as ion, and this is your atom. Let's say for magnesium, this is what? This is atom. If I put Mg2 positive, then what it will be? Ion. So what I have seen, that if I put a charge over the atom, then it will be considered as your ion. So what are ions? Ions are the charge carriers. So compound composed of metals and non-metals contain charge species. These charge species are known as ions. So what are your ions? Ions are the charge species. They are metals also and there are non-metals also. But there are two types of ions, that is cation and anion. What is cation? When it is having positive charge. If an ion is having this positive charge, then it is termed as your cation. If an ion will be having negative charge, then it will termed as anion. So there are two types of ion, cation and anion. But the thing is, why this concept come, or why this we are having? Yes, Aslam, if there are positive charge, then it will be your what? Cation. If there are negative charge, then it will be your anion. Now, why this ion concept is there? Why, ma'am, and anion means negative? Yes, Aslam, you are correct. So here, if I talk about ions, how this concept came, there are metals and there are non-metals. Let's say we are taking an example of sodium chloride, NaCl, correct? Now, if I say the atomic or electronic configuration for sodium, then what will be the electronic arrangement for sodium? If I talk about sodium, then its atomic number is 11, that is 2, 8, 1. This is the electronic arrangement for your sodium. For chlorine, it is 17, that is 2, 8, 7. Now, we know that atoms are stable when they are having completely filled shell, or they are completing their octet. If their octet is complete, then they are considered as to be stable. So for octet, how many electrons should be there? 8. Now if you see, this is the outermost shell for sodium, this is the outermost shell for chlorine, and if I talk about chlorine, it is having only 7 electron. 7 electron, that means it requires one more electron to become stable. For sodium, it will require how many electrons? Either it can gain 7 electron or it will lose 1 electron and then it will become stable. So what sodium will do? Sodium has 1 valence electron in the last shell and chlorine has 7 valence electron in its last shell. So they want to become stable. So what sodium will do? Sodium will give its 1 electron to this chlorine. And while giving this electron, how many electron will be there? 8 electron will be there in the chlorine atom. And what about sodium? If I talk about sodium, then its electronic arrangement will be 2, 8, 1, and 1 is the valence electron. That means it will share 1 electron, or it will not share, it will transfer 1 electron, then it will become 2, 8. Now sodium has lost its 1 electron and it will become 2,8. Then chlorine, what about chlorine? Chlorine will take this one electron, initially it will be having 2,8,7. भाई पहले इसके पास 7 इलेक्ट्रॉन थे ना, 7 वैलेंस इलेक्ट्रॉन थे, अब उसने सोडियम से एक इलेक्ट्रॉन ले लिया है. यस, सो यस मृदुला, lose one. Mridula, you are from practically only, I think. So, this electron was taken by this chlorine, and what will happen? It will take and form 2,8,8. Correct? This is the electronic arrangement for your chlorine. Now you can see sodium and chlorine both have 8 electron in the last shell. Both have 8 electron in the last shell, and now they are stable because their octet is completed. Correct? Now what will happen? Sodium will give its 1 electron, it will become sodium positive. So whenever an element is losing electron, it will gain the positive charge, and chlorine will gain this electron, so it will become negative. So if it is losing, then it will gain this positive charge. If it is taking this electron, then it will, or taking or gaining, whatever you want to use. So gaining of this 1 electron will get this negative charge. Okay, Aslam, you are also from practical only. Okay. So you are late today. Why? I don't know. Mridula and all. So this is how the charge species form. So whatever I get from here is ions are formed. Why? Because these atom wants to be stable. And how they will become stable? Either by losing electron or gaining electron. If it is losing electron, then it will got the positive charge. If it is gaining electron, then it will become negatively charged. Okay. So this is how charge species form, or you can say ions form. Okay, ma'am, entrepreneur class is there. Okay, Rizula. So this is how the charge are formed. Sodium lose electron, positive charge. Chlorine gain electron, negative charge. Positive means your cation and negative means your anion. So these are all about ions. Now sodium, symbol is Na. What is the valency of sodium? +1. Now ma'am, where does this valency come from? If you see this, sodium is losing 1 electron, correct? So what will be the valency of sodium? Its valency is 1. Chlorine is gaining that 1 electron, so what will be the valency of chlorine? It is also 1. So what is valency? Valency is the combining capacity. Okay, we will learn this in the later on slide. So this is the table which is given in your NCERT. So let's talk about first valency. If I talking about valency, yes Aslam, if it lose, then it will gain positive charge. Okay, if it will gain the electron, then it will be having negative charge. So valency is the combining power, or you can say capacity of an element is known as its valency. What about this valency? Where does this concept come from? So we got to know about ions. What we have seen, that sodium having incompleted, or it is having incomplete octet, that is only 1 electron in the outermost shell. It needs 7 electron. Now what sodium will do? It will just lose 1 electron and forming 2,8 of electronic arrangement, and now it is stable. What about chlorine? What we have seen in chlorine, it is having negative charge. Earlier it is having the electronic arrangement 2,8,7, and now after gaining 1 electron, its electronic arrangement will become 2,8,8. So here this sodium loses 1 electron. This is the valency of sodium. Chlorine gained 1 electron. This is the valency of chlorine, that is 1 is the valency of sodium, one is also the valency of chlorine. And they do so to become stable. So whenever there is a valency, why they share or lose electron? To become stable. And what about valency? They share or lose or gain electron to become stable, and the number of electron they will share or gain or lose, that is termed as your valency. Let us understand in a more better way. The outermost shell of an atom contain the valence electron. That's correct. If someone asks you what are valence electron, so the number of electrons which are present in the outermost shell. Okay, the number of valence electron which are present in the outermost shell. Let's say for sodium, the electronic arrangement will be 2, 8, 1. So here, what is the valence number of valence electron? Only 1, because this is the outermost shell. And we got to know that whenever there is a outer shell and the number of electron which are present in the outermost shell is termed as your valence electron. For chlorine, what will be the valence electron? 7, because this is the last shell of your chlorine. So it is having 7 electron. That's why these are the, if I talk about the valence electron of chlorine, it comes out to be 7 only. Okay. So valency is what? Combining capacity. How they are combining? Why they use this word combining? Look, this is your sodium. This is your chlorine. Now sodium become positively charged. Your chlorine become negatively charged. Now they are oppositely charged. Okay, this is positive, this is negative. What they will do? They will attract each other to form a bond, and they will form NaCl, which is called your sodium chloride. Which is called your sodium chloride. So NaCl is what? How they will form? Because Na forms Na positive, Cl forms Cl negative. Now they are oppositely charged and they will attract each other and form a compound, that is NaCl, that is your salt, common salt, table salt, or sodium chloride, whatever you want to say, you can say. Okay. So this is how after gaining or losing electron, they will combine with each other, and this is called what? Your valency. Let's take another example of magnesium. If I talk about magnesium, then magnesium has atomic number 12. Okay. Now, if I write the electronic arrangement for magnesium, it will be 2, 8, 2. Correct? 2, 8, 2. So, how many valence electron are there? 2, because what are valence electron? The electrons which are present in the outermost shell. So 2 are the outermost electron. 2 valence electron are there. Now 2 valence electron are there. It want to have 8 electron. That means it requires 6 more electron. Correct? This magnesium requires 6 more electron. Now what it will do? Can it gain 6 more electron? It is very hard for magnesium to gain that much 6 electron. It is easier to just lose 2 electron and form the electronic arrangement of 2, 8. So what magnesium will do? Magnesium just lose these 2 electron and form Mg di positive, so that it will become stable. So magnesium lose 2 electron, it will form Mg di positive, and now it is stable. So what is the valency of magnesium? It's 2. If an element is losing 3 electron, then it is having valency of 3. If it is gaining 2 electrons, then it is having valency of 2. Okay, so let us find the trick for this calculating this valency. Look, there are 2-3 things. If your number of valence electron, now I hope you all understood about valence electron. That means the electrons which are present in the outermost shell. Now if the number of valence electron is less than 4, then your valence electron is equal to your valency. Or if your number of valence electron is greater than 4, then 8 minus valence electron will be giving you the valency. This is the trick for your calculating valency. Yes. So here, if let's say we will talk about this lithium. Okay. What will be the valency for lithium? What is the atomic number of lithium? That is 3. How many valence electrons are there? In the first shell, 2 electrons are there. But if I talk about the second shell, only 1 electron is there. That means this is the outermost shell for your lithium. It is having only 1 valence electron. 1 valence electron means it can lose 1 electron. If it is losing 1 electron, then what will be the valency of lithium? That is 1. This is the proper way. Now, if we want to calculate by this trick, so we are having 1 valence electron, that is less than 4. So valence electron equals to valency. That means valence electron is 1. So the valency will also be 1. Let's say for your oxygen. Okay. Now oxygen have atomic number 8. Correct. How many valence electron are there in oxygen? If I want to write, so 2 in the first shell, then 6 in the second shell. Now 6 valence electron are there in your oxygen. Correct. So 6 valence electron, that means more than 4. Valence electron are more than 4. So what they will do? 8 minus valence electron. That means 8 minus 6. How many valence electron are there in oxygen? 6. So 8 minus 6, which gives you 2. So the valency of oxygen will be 2 only. So this is how you need to calculate. If the number of valence electron are less than 4, so the number of valence electron is equal to valency. Here lithium has only 1 valence electron, which is less than 4. So the valency is also 1. If we are having 2 valence electron, then the valency is also 2. What about this? If the number of valence electron are more than 4, then subtract it from 8. Like oxygen has how many valence electrons? 6. So 8 minus 6 gives us 2. That is 2 valency. So these are the valency you should remember. And remember this thing, your noble gases, they have the valency 0. Noble gases have valency 0. Why? Let's talk about your neon. Okay. If I talk about neon, the neon has atomic number 10. That is 2, 8. Now number of valence electron 8. So 8, that is your more than 4. So 8 minus 8 gives you 0. And if you want to know the reason behind it, we know that it is already have completely filled octet. It is having 8 electron. Now why it want to react? Neither it will gain or lose electron. So it is stable. So it won't give or neither it will gain the electron. So the valency will be 0. Hey Sneha. Okay. So any confusion in valency? If you are having any confusion, then let me know. Write yes or no. Ma'am, can you repeat? Okay. So we have learnt about the valency. What is valency? Valency is the combining capacity of an element. So whenever we are having this valency, why there is a concept of this valency? Because element will gain or lose or share electron, and when they lose or gain or share these electron, they are termed as their valency. Aslam, you said no. Which topic, which part you will find difficult to understand? Please let me know. I will explain that part. ओके एक बार मैं हिंदी में भी इसे समझा देती हूँ. वैलेंसी को हम कंबाइनिंग कैपेसिटी कहते हैं. ठीक है. अगर हमारे पास इनकम्प्लीट ऑक्टेट है, दैट मीन्स हमारे आउटर मोस्ट शेल में अगर 8 इलेक्ट्रॉन्स नहीं है, तो क्या करेगा कोई एटम? या तो वो इलेक्ट्रॉन लेगा या तो उसे लूज करेगा. ओके, या तो वो इलेक्ट्रॉन लेगा या तो वो उसे लूज करेगा. तो वो इलेक्ट्रॉन अगर 1 इलेक्ट्रॉन ले रहा है या 2 इलेक्ट्रॉन ले रहा है तो वैलेंसी क्या हो जाएगी 1 या 2। अगर वो 2 इलेक्ट्रॉन गेन कर रहा है या 1 इलेक्ट्रॉन गेन कर रहा है तो उसकी वैलेंसी क्या हो जाएगी 1 एंड 2। ओके, आपको ये फॉर्मूला समझ में नहीं आया, दैट मीन्स यू डिडंट अंडरस्टैंड द ट्रिक। नाउ लेट्स टेक अनदर एग्जांपल, लेट्स से फॉर बोरोन। ओके, नाउ बोरोन हैव द atomic number 5. Where should I write? Okay, boron has the atomic number 5. Correct, boron has atomic number 5. If I want to write the electronic arrangement 2, 3. Now the number of valence electron are less than 4. Correct, number of valence electron are less than 4. We know this, that 3 is less than 4. Correct, we know this thing, that 3 is less than 4. Now number of valence electron if less than 4, then we write the number of valence electron as their valency. मतलब जो भी जितने भी वैलेंस इलेक्ट्रॉन होंगे वो सारे के सारे क्या होंगे वैलेंसी में कम आएंगे। मैम वेयर आर यू टीचिंग फ्रॉम? आई एम टीचिंग फ्रॉम आवर हेडक्वार्टर्स ओनली। So number of valence electron is equal to your valency. That means if you are having 4 valence electron, less than 4 valence electron, then your valency will be that only. If it is having 3 valence electron, then the valency will be 3. If it is having 2 valence electron, the valency will be 2. If it is having 1 valence electron, the valency will be 1. If it is having more than 4 valence electron, let's say for your nitrogen, the atomic number is 7, that is 2, 5. It is more than 4, that is the number of valence electron is more than 4. So what I will do? I will subtract it from 8. 8 minus 5, that is 3. So this is the valency of nitrogen. This is the simple trick. If you know what is, Aslam, you know now what is valence electron. Just you need to calculate how many valence electrons are there. If there are more than 4, then just subtract it from 8. If they are less than 4, then write the number of valence electron as their valency. That means if there are 3 valence electron, then the valency will be 3 only. If there are 2 valence electron, then the valency will be 2 only. Now got it, Aslam, or not? Just let me know. Anyone else who wants to ask anything? Then we will move forward to writing this chemical formula. Ma'am, 8 is constant. So here, yes, why 8? Because there is a reason. If it is 4, Charan, if it is 4, then the valency will also be 4. Like for carbon, okay? For carbon, we know the valency will be 4. So Aslam is asking that 8 is constant. Why we are subtracting it from 8? Because the number of valence electron that we need to acquire, we need to complete its octet, and octet is completed when there are 8 electrons. Correct? When there are 8 electrons, then the octet will be completed. That's why we are subtracting it from 8. मैम इस बार का सब्जेक्टिव पेपर है एक्स्ट्रा क्वेश्चन. सो स्नेहा, you joined late. Actually we are focusing on that only for subjective paper. That's why we prepared some important question for this. We are also conducting this sample paper series, so it will benefit you. So we are taking care of this thing also, that we will provide this whole subjective thing, how you will write the answer in the question paper. Ma'am, doubt. Yes, hello gamer, you can ask your doubt. You all are coming late, or what happened? Ma'am, why phosphorus has tetraatomic? So basically, your phosphorus, there are many kinds of phosphorus, like white phosphorus, red phosphorus. So there, if I talk about phosphorus, so it will combine in this form. Okay, it will combine in this form. So if I talk about sulfur, then sulfur will be in the 8 form. If I talk about oxygen, Okay, it will be 2. Why these atomicity 2, 4, 8 are there? Because they will become stable only in that condition. Okay, if I am talking about phosphorus, then what it will do, it will combine with the other 3 phosphorus and then it will become stable. That's why it is tetraatomic. For oxygen, I have told you na, that oxygen, let's take a simple example. Oxygen, how many valence electron are there? 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what they will do? They will share 2 electron and now their octet are complete. That's why they exist as O2. So this whole thing, whatever we are performing, whatever we are doing in chemistry, this whole thing is based on your what? Is based on your stability. You want to become stable, whatever, in the whole universe. If let's take our example. Okay, let's take our example. Why we are doing so much of hard work? Why you are studying? Why we are doing jobs? Because we want our stability, we want our life to be stable. That's why we are doing all this. Okay, everyone doing anything to become stable. So similarly with the atoms, whatever goes on in chemistry, that ultimately comes to that point that it want to become stable. What is meant by tetraatomic? Tetra means 4. So there should be 4. If I talk about di, it means 1. Okay, di means, sorry, mono means 1, di means 2, tri means 3, tetra means 4, and more than 4 we will use polyatomic. So mono मतलब एक एटम, सिंगल एटम एग्जिस्ट कर सकता है. So सिंगल एटम कहाँ एग्जिस्ट कर सकता है? Helium, neon, argon, these are all are noble gases. So these noble gases are monoatomic. Why they are monoatomic? क्योंकि वो stable है, उनके octet पहले से ही complete है, so they won't react. So noble gases are stable. They are what? They are monoatomic. But if I talk about oxygen, hydrogen, nitrogen, they are diatomic because they are stable only at that point. If I talk about your this triatomic, can anyone give me the example of triatomic? Which atom or which element have this triatomic atomicity? Can anyone give example of that? Ma'am, what is ion? Actually, you all are coming late. I have already completed this. So ion are what? They are charge carriers. I have explained this thing in full detail. Okay. So anyone can give this example? What is this? What I have asked? What I have asked? This example of triatomic. Can anyone tell me example of triatomic? No one. Triatomic example is ozone, O3. So if O2 is there, then it is diatomic, that is oxygen. O3, ozone, that is triatomic. So this is how this is how atoms combine in your nature. And if you know the atomicity, you can easily write the chemical reactions. Okay. So now let's talk about writing chemical formula. So we have now known to these symbols. We already know how we can write the symbol. Now we got to know about the valency thing also. Okay. Let's talk about this HCl. Look, something are there which you should need to remember, like some of the valency. Sometimes there are some confusion, so you need to remember all these things. So whatever given in your NCERT table, you should remember that. Like your atomic masses, you can't calculate them, so you need to remember. You can calculate valency easily, but you should know what is the atomic number, what will be the number of valence electron, how to write an electronic arrangement. But this thing you can do it very easily if you have this clear concept. But if you don't have this clarity of concept, then what will you do? You just need to remember all of these. Okay, so if you remember all of these, then you can easily answer the question. Otherwise, what you can do, just remember or just learn the concept from very basic to the high level, so that whenever any question is there, you can easily answer that. Carbon dioxide, ozone, water. That's correct. That's correct, Aslam. Okay. Now let's talk about chemical formula. Now for chemical formula, you should remember 2-3 things. Let's say I am writing hydrochloric acid, or simple I can write hydrogen chloride. Why should I confuse you? Hydrogen chloride. Now, I need to write the chemical formula for hydrogen chloride. What will be the symbol for hydrogen? That is capital H. What will be the symbol for chlorine? Capital C, small n. Correct? Capital H, capital C, small s. This is the symbol. This we have already discussed, who have came late. So please watch the previous slides also, so that you have the clear conceptual clarity. So for hydrogen and chloride, H is the symbol for hydrogen, Cl will be the symbol for chlorine. Now you need to write the valency. This is the element, this is the valency. So what is the valency of hydrogen? 1. What is the valency of chlorine? 1. Now cross multiply it. What you will get? H1Cl1, or simply you can write HCl. This is the chemical formula for your hydrogen chloride. That's correct, Sneha. That's correct. Okay. So here valency will be 1, 1. Cross multiply it. You will get the chemical formula. So from here, what you got to know? First of all, you need to remember the symbol for the elements. Like for hydrogen chloride, hydrogen symbol is capital H. For chlorine, it is Cl. Now cross multiply with their valencies and you will get the chemical formula. Next example is what? Your magnesium chloride. Okay, magnesium chloride. Now magnesium has the valency of 2. Chlorine has the valency of 1. Now cross multiply it. Now I have cross multiplied it. I will get MgCl2. This is the chemical formula for magnesium chloride. This is clear or not? Tell me one thing. If it is not clear, then I will repeat it once again. Yes. Remember this thing. Whenever you are writing chemical formula, Charan, Mg, if you are writing Mg, put capital M. Okay. If it is seeing wrong, then it should be capital M. It is capital M, small g. For chlorine, capital C, small l. Okay. Aslam says yes. Okay. It's clear. Okay. Now, let's move towards the question. So, magnesium chloride will be having the formula of MgCl2. We have done this already. Now, tell me the formula for calcium oxide. I am waiting for your answer. Quickly calculate the chemical formula for calcium oxide. Let's see who will answer this question first. Very simple. You just need to write the element, then their valency, and cross multiply it. You will get the answer. Aslam, Charan, Sneha. Oh, Lakshmana, you are late. Yes, ma'am, for this capital only. I am beated my class, ma'am. I am beated my class, ma'am. What does that mean? Calcium oxide formula. Tell me quickly. Why Lakshmana? Okay, for this only. Okay. Now you will remember this for your whole life. This thing happen. If you are beaten by your teacher, then you will remember it for your whole life. Okay. So Charan says Ca, calcium. I am asking for chemical formula for calcium oxide. Okay, Aslam says CO. Let's see if Aslam is correct or not. Where is Sneha's answer? So calcium oxide, Ca, oxide means O. Correct? Calcium oxide. What is the valency of calcium? 2. What is the valency of oxygen? 2. Cross multiply it. You will get Ca2O2. That means CaO. Simply. Okay. We can cancel it 2 and we will get CaO. So this is the formula for your calcium oxide. This is how you need to calculate the chemical formulas. Now if I talk about copper nitrate. So copper symbol is Cu, capital C, small u. Then nitrate, NO3. What will be the valency of copper? That is 2. Nitrate 1. Cross multiply it. What you will get? CuNO3 whole twice. Okay. Just you need to cross multiply. You need to remember these valencies. For your aluminium chloride. For aluminium chloride, I am having Al, Cl. Aluminium valency 3, Cl valency 1. What will I get? AlCl3. If I talk about calcium carbonate, calcium is Ca, carbonate is CO3. So calcium 2, carbonate is 2. So CaCO3. Okay, this is the formula for calcium carbonate. Ammonium hydroxide, for ammonia it is NH4. This is hydroxide, that is OH. This is 1, this is 1. Cross multiply, we will get NH4OH. This is how you need to remember things. This is how you need to answer for that particular question. So this is the question that has been asked in your previous previous examination. So you should know how to write your answers. Okay. Now let's talk about our last topic, that is your mole concept. Now you all are afraid of this mole concept, correct? But what is that mole concept? Why it is so big or so confusing and all? But the thing is, if you know the concept behind this mole concept, you can easily calculate all the formulas, all the questions, all the things, whatever they have asked. Okay. But what do you understand by the term mole? What is that? Okay, Aslam is saying mole is the measure of atom. Simply, if I want to explain it in simple way, if you are having this CaC2, that is calcium carbide, that is calcium sulfide. Okay. No copyright songs. Why are you laughing? Have you heard a joke? Okay. So let's talk about this mole concept. Okay. Now we are having mole as a unit to calculate a particular amount of a substance. So mole is the unit of amount of substance. Simple. 2-3 things. I will write here. Mole is the unit of amount of substance. Correct? Now, this is mole unit. Okay? Mole is a unit for the amount of substance. What does that mean? Look, whenever you are going to buy apple or whenever you are going to buy banana, let's say for banana, in what unit you will buy the bananas? In dozen. In 1 dozen, we are having 12 pieces. Correct? We are having these 12 pieces. This is your 1 dozen. But if I want to talk about matter, okay, a particular element, if I am talking about this oxygen element, okay, how many atoms are there in that particular oxygen element? Can anybody tell me? We can't determine the amount of atom or the number of atom in 12, 13, 14 or 100 or 1000, because there are millions of atom inside this particular oxygen atom. Correct? We are having millions of atom. So this millions of atom, what particular unit we have given? We have given this mole. Correct. So millions of atoms are there. We can't say that 100 atoms are there or 1000 atoms are there. So this is why we need to introduce mole. For bananas, we can take 12. For a gross, we can say 144 bottles. Okay, if I have said 1 gross of bottle, that means I am having 144 bottles. But if I am talking about matter, atom, molecules, ions, they are present in millions of number. Can I define it in 1000 or 10 lakh or 1 crore? No, I can't define. So I have to introduce a new unit for this calculating number of atoms or number of ions or number of particles. And what was that new concept? This is your mole. So mole is a unit to calculate or just to have the amount of substance. If you are having a particular amount of substance, its unit should be mole. Why it is mole? Because mole is a very large quantity. Let's look at this number. This is 6.022 into 10 ki power 23. That is what? This is your Avogadro number. Okay. So if I want to define mole, then 1 mole of any species, that means it can be your atom, molecule, ion or particle, is that quantity in number having a mass equal to atomic or molecular mass in grams. Okay, are you getting this point? So I will once repeat this. What is mole? Mole is a unit for the amount of substance. Why we need this unit? Because in a particular matter, compound or element, we are having how many atoms? Millions of atoms. How can we calculate or how can we find that these millions of atoms are present in a particular compound or element? So what I will do, I will introduce a new unit for this, and that unit is mole. Okay, Aslam. That's good. Hi, Sarabjit. Okay, I have seen your message. So let's get back to this mole concept. So what is mole concept? That is, if you want to calculate the number of atoms, number of molecules, number of ions or number of particles, what I need to do? I need to define a term that is mole, and this mole is what? Is a unit for amount of substance. And in 1 moles, how many particles are there? 6.022 into 10 ki power 23. And what is this? This is Avogadro number, Na, which is represented by Na. Okay, so this is represented by Na. This is simple mole. If you want to repeat it in Hindi, so I will tell, mole एक unit है किसी amount of substance की. Correct? If you are having a particular amount of substance, then you can represent it in the form of mole. अब एक किसी भी एटम, किसी भी एलिमेंट में या फिर किसी भी कंपाउंड में या फिर किसी भी मैटर में मिलियंस ऑफ एटम्स हो सकते हैं. तो वो मिलियंस ऑफ एटम्स हम 1000 में हम रिप्रेजेंट नहीं कर पा रहे हैं, हम उसे करोड़ की वैल्यू में रिप्रेजेंट नहीं कर पा रहे हैं, क्योंकि हमें फिक्स नहीं पता कि भाई कितने हमारे पास वो एटम्स हैं या फिर वो आयंस है या फिर वो कोई पार्टिकल है. तो हमने उसके लिए एक नया टर्म निकाला, एक नई यूनिट निकाली जिसे हम मोल बोलते हैं. ठीक है. और अगर हम एक मोल की बात करें तो एक मोल, 1 मोल इज इक्वल टू हाउ मेनी नंबर्स, हाउ मेनी पार्टिकल्स या हाउ मेनी आयंस, दैट इज 6.022 into 10 की पावर 23. करेक्ट. Now let us look at the video. Okay. So mole is the amount of substance that contain as many particles as there in atom in exactly 12 gram of carbon 12 of isotope. So this is the older definition for mole. Okay. So mole is what? Having 6.022 into 10 की power 23 particles. So एक मोल में हमारे इतने पार्टिकल्स या इतने एटम्स या इतने आयंस होते हैं, और ये 6.022 into 10 की power 23, what is it? It is your Avogadro number. So mass of 1 mole of substance is your relative atomic mass or relative gram molecular mass. So if I want to talk about this relative atomic mass or gram molecular mass, so we will represent it in the form of your gram. Okay. The mass of 1 mole of any substance in gram is called molar mass. अगर हम किसी भी substance को, if we represent any mass in the form of gram, then we will call it as molar mass. So molar mass of sulfuric acid is 98 gram. So we are representing this sulfuric acid mass in terms of your gram. So gram atomic mass, 1 mole atomic weight of a substance is called as gram atomic mass. Like for oxygen, what is the atomic mass of oxygen? That is 16. 1 mole of atom of oxygen, if I am talking about molar mass, that is we need to represent in the form of gram. 1 mole molecular weight of a substance is termed as 1 gram molecule. That means if I am talking about oxygen molecule, then the molecular weight will be 32 gram. If I am talking about oxygen atom, that is 16 gram. If I am talking about molecule, then it will be 32 gram. This is the question: how many number of moles of glucose are present in 540 gram of glucose? So the molecular formula of glucose is C6H12O6. The mass will come out to be 180. So 1 mole of glucose is having 180 gram. So 180 gram of glucose, that means 1 mole of glucose. I will re-explain it again. So for 540 gram, how many moles of glucose are there? 3 moles of glucose are there. Okay. So if I want to calculate the number of moles, then the given weight upon gram molecular weight is equals to number of moles, where N is the number of moles, W is the weight of the substance, and M is the molar mass. Now, what is explained in this video? Okay, what was explained in that video? Let's see. So here, let's look. Ma'am, what is the timetable for class 11th student? Please tell me. Okay, Sarabjit, I will tell. Basically, just go to the Practically app. Okay, download this Practically app, and if you are enrolled for the course, then you will get the timetable. Okay, and for YouTube classes, the YouTube classes conducted from around 8 to your 10. Okay, from 8 to 10 we conduct our 11th-12th classes. Okay, TK King Gaming Channel. Oh my god, name is so big. Good night. Okay, good night. So for this, if I want to say about this mole concept, whatever we have learned here, so if you need to calculate number of moles, then what will be the formula? For number of moles, your given mass upon molar mass. What is this molar mass? Let's take simple example. Oxygen atom and oxygen molecule. This is oxygen atom. This is oxygen molecule. If I am talking about oxygen atom, then what will be the mass of this oxygen atom? That means 16U. U stand for unified mass. Earlier we used AMU, that is atomic mass unit. Okay. And now we are using this U instead of AMU, that stands for unified mass. So oxygen have a mass of 16U, and O2, that is oxygen gas. So O2 will have how much mass? There are 2 oxygen. Each oxygen will have 16 mass. So if I calculate, it comes out to be 32U. So if you see this, if I am talking about atom, then the mass is 16U. If I am talking about oxygen molecule, then its mass is 32U. What do you understand by this? That if I am talking about any atom, I am considering only one atom. And if I am talking about O2, then I am talking about the molecule. Now what about molar mass? If I represent this thing in grams, if I write 16 gram, then it is called molar mass. Why? Is there any difference between this 16U and 16 gram? Do you think is there any difference? Yes, there is a big difference. 16U means only one oxygen atom and 16 gram means 1 mole of oxygen atom. What does that mean, 1 mole of oxygen atom? That means how many oxygen atoms are there? 6.022 into 10 ki power 23. That much oxygen atoms are there. So, if I am writing 16U, that means only one oxygen atom. If I am writing 16 gram, that means 1 mole of oxygen. And what does this 1 mole stand for? That means 6.022 into 10 to the power 23 atoms are there. Yes, Aslam, you can ask. So, this is the difference between U and gram. If you are writing only U, that means you are representing only one atom. If you are writing G, then it is what? It is your 1 mole of that particular atom. And 1 mole, how many atoms it is containing? 6.022 into 10 ki power 23 atoms it is containing. Okay. So, how we calculate the mass of glucose? So, the question is C6H12O6, this is the formula for glucose. If I want to calculate the mass for that glucose, then carbon has 12 atomic mass. How many atoms are there? 6. Hydrogen have 1 into 12. Oxygen have how much? 16 into 6. If you calculate, you get a particular value. This is the molar mass of glucose. This comes out to be the molar mass of glucose. So here, whatever, so we have given the mass of 540 glucose. Okay, so we need to calculate how many moles are there in 540 gram of glucose. This is what they asked. So what we did, we know that if we calculate the formula unit mass for glucose, we get some value. And how to calculate the number of moles? Just you put N equals to given mass upon molar mass. Given mass is 540. Molar mass comes out to be, let's say, X. Divided by X, you will get the number of moles. So whenever you are having this number given mass and molar mass, then what you will do? Okay, it comes out to be 180. So divided by 180 and you will get what? 3. Okay, so 3 moles are there. So whenever you are given a mass, what you will do? You will put here, then calculate the molar mass, divided by here, and you will get your number of moles. Okay, your form, ma'am, this is my doubt, ma'am. How to calculate this 180? How to calculate the molar mass for this? N equals to given mass. Yes, this is the formula for calculating number of moles. If you want to find out the number of moles, then what will you do? N equals to given mass upon molar mass. This is the formula for calculating number of moles. So you have given already a particular mass, like 540 they have given. Just put here, calculate the molar mass from here. Whatever compound they have given. Let's say they have given water. Let's say they have given water. So what will I do? 2 into 1, because mass of hydrogen is 1. Oxygen is 16. So it comes out to be 18. So the molar mass of your water is 18. So Kartika or Lakshmana Prabhu is saying, ma'am, but in 9th standard we have learned two formula, but exercise I get confused. For example, the number, if yeah, we will do this. We will do this, Lakshmana. In the next slide, we will do this problem solving also. Hi AS program, good evening. You are very, very late. So this is what they asked and how we have calculated. Let's do some problems over this. Convert into mole. So we are having 12 gram of oxygen gas. So this is the given mass. 12 gram is the given mass here. Now if I want to see this oxygen gas means O or O2. Answer quickly. Oxygen gas is O or O2. This is A option, this is B option. Answer this. Oxygen gas is A or B? What do you think? Should I take only O or O2? Okay, Aslam says O. A. Okay, anyone else? So here, this is the main thing where you are getting confused. Okay, we never take O. I told you, whenever you are taking any this thing, any reaction, anything, then you need to know the atomicity. Oxygen is a diatomic. Why it is diatomic? Because in nature we find oxygen as O2. Okay, so oxygen gas is always O2. Oxygen gas is O2. So remember these small things where you will get confused. That's why you are unable to solve the mole problems. Okay. So here 12 gram of oxygen gas. So we need to calculate the mole now. What we have learned from this, that the number of moles is equal to given mass upon molar mass. Correct? Given mass upon molar mass. Now here given mass is 12 gram. Molar mass is what? Oxygen, that is O2. O2 means 16. One oxygen atom has the mass of 16. And how many atoms are there? 2. That comes out to be 32. So 12 upon 32, whatever the answer is there, it is the number of moles. Hi Amit. So the number of moles comes out to be how much? 0.35375. Okay. So this is how you need to calculate the answer. First of all, whatever the given mass is there, then you need to calculate whatever compound you have given or molecule you have given. Like for oxygen gas, it is O2. Then it means you have to take mass of one oxygen atom, and how many atoms of oxygen are there? 2. So multiply it by 2, you will get 32. Let's take one more example to understand it better. For 20 gram of water, that means 20 gram of water, that means what? Okay, I will do it in without using this formula. I will do it by unitary method. Okay, by unitary method. So here, if I talk about water, then what will be the formula for water? H2O. Okay, so 1 mole of water, or simply I can say, how if I want to calculate 1 mole of water, then how many hydrogen atoms are there? 2. Okay. What is the atomic mass for hydrogen? 1. Oxygen mass is 16. So it will give me 18 gram. So 18 gram of water will contain 1 mole. Okay. Then 20 gram of water contain how many mole? 20 gram of water contain how many mole? So 1 upon 18 into 20, which comes out to be how much? How much? It is 1 point something. Okay. So that much it is coming out, that is 1.1. Okay. If you see the answer, it is 1.111 moles. So here what we have seen, either you want to apply unitary method, you can apply this. If you want to apply this formula, you can apply this. Let's solve it by applying formula also. So N is the number of moles. So given mass is 20 grams. Molar mass is what? It comes out to be how much? 18 grams. So 20 by 18, 20 by 18, 20 by 18, whatever you want to, which method you will prefer, it will be completely fine. So this is the direct formula for calculating number of moles, that is N equals to M upon what? M upon capital M is your given mass upon molar mass. Okay. So this is N equals to small m by capital M. Small m is your given mass and capital M is your molar mass. Okay. So this is the third question. 22 gram of carbon dioxide, you need to calculate the moles. So 22, and if you want to calculate for carbon dioxide, that is 12 plus 16 into 2, that gives you 32 plus 12, which gives you 44. Okay, so divided by 44 comes out to be half, that is 0.5 moles. This is how you need to calculate. Yes, both are correct. Both are correct. Now calculate the formula unit mass for zinc oxide Na2 K2CO3 when you have given this mass. For zinc oxide, zinc is how much? The mass of zinc is 65. For oxygen, the mass is 16. So 65 plus 16, 5 plus 6, that gives me 1 and 6, 7, 8, 81 U. This is the formula of unit mass for zinc oxide. For your Na2O, that is sodium is having how much mass? 23 into 2 plus oxygen, that is 16. So 6, 46 plus 16 gives you 2, 4, 5, 62. Okay. For K2CO3, potassium is 39 into 2 plus 16, 3 into 32. It will be a long calculation, so you can do it by yourself. Hi Mahendra. Okay, this is the answer that comes out to be 138 U. This is how the question can be asked and you need to answer them. Okay, but this is not necessary that this is given to you. So you need to learn all these atomic masses which are present in your NCERT table. Okay. Give 1 point of difference between an atom and an ion. If I talk about atom, then atom does not contain any charge, while ion do. Ion contains positive or negative charge. If they are containing positive charge, then it will be termed as your cation, and if it is carrying negative charge, then it will be your anion. Give one example each of polyatomic cation and anion. Let's see. Here NH4 positive. NH4 positive. Here you can see why it is calling polyatomic. Polyatomic means more than one atom. So here 1, 2. So there are 5 atoms are there, like nitrogen 1 having 4 hydrogen atoms. So they are polyatomic. So positive charge it is having. So it is polyatomic cation. Polyatomic anion is what? Like SO4 negative or like OH negative. These all are polyatomic ions. Okay. So you should remember all these. Identify the correct formula for FeSO3. That is FeSO3. That is your what? Ferrous sulfide. Ferrous sulfide. Because FeSO4 is your ferrous sulfate and FeS is your ferrous sulfide. Okay. Then write the chemical formula for the chloride of magnesium. We have already done this, MgCl2. Okay. Because magnesium and chlorine, 2 it is having valency, it is having 1 valency, crisscross, we will get MgCl2. This should be your answer. Okay, MgCl2, it is not visible, MgCl2. Okay. So we have completed this chapter. I hope you got this thing and you have now no confusion. So this is our whole schedule for class 9th, and this is for coding. So do attend the lecture. We will meet in the next session. Till then, bye-bye. Thank you. And that's all. Thank you.